Good morning, good afternoon, good evening. Welcome wherever you are in the world to this, our third week of machine learning for beginners. Now, if you've joined any of our previous sessions, you'll know this is a conversation. If you're new to this, again, this is where we want to talk to you. So we are going to be sharing great content, but we want to ask you questions and we want to answer your questions. We want you to jump in the chat and get as involved as much as possible as you can. However, we do ask that you follow our code of conduct. We've dropped a link to it into the chat. We'll get that pinned. But please, please, please follow our code of conduct. Ask questions, get involved, give us your comments, but don't be a jerk or we'll kick you off and ban you from all Microsoft events. We have a large team of lawyers. Don't mess with us. And with that, once again, I'm joined by B. Stolnitz. Very happy to have B with me. B, do you want to say hello? Introduce yourself.
Hello, everybody. My name is B. Stolnitz, and I'm a principal advocate on the AI/ML team at Microsoft. I focus on technologies such as Azure ML and the Azure OpenAI service. But today, I'm really here to talk to you about regression, linear regression, right? So we're going to talk about some of the basics. So please ask your questions, and Jim and I will do the best to answer them.
Awesome, cool, thank you. So welcome everyone who's here. So if everyone just jump in the chat, say hello, let us know whether you watch the videos. The structure we've been doing over the past few weeks is we drop some videos on the Monday and then we do live streams at the end of the week to answer your questions, kind of go through it in more detail. So jump in the chat, say hello, say whether you've watched the videos, say whether you joined us last week. We've had a few folks coming back time after time. So yeah, welcome everyone. Jump in and say hello. We've got our first question here, actually.
It's
Jeremy
a good
asked,
question. It's not a stupid question. It's a good question, Jeremy.
There's no such thing as a stupid question. I will say this. No such thing as a stupid question. Just to be sure I'm not falling behind, where should I be at this point in the course? Great question. So for those who haven't joined us before, I'm going to just share my screen. What we're doing is we're kind of working through the Microsoft ML for Beginners curriculum. So this is a free open source 26 lesson curriculum designed to teach you classical machine learning literally from the basics. We start right at the basics. I'm just going to drop a link to it in the chat. Bear with me while I do the typing thing. Link in the chat. And so what we've been doing is we've been creating some short videos that work through some of the content. B has been the star of these videos. We drop some videos every Monday with 4 or 5 videos a week, and then we do these live streams, kind of work through it. And we've been working through kind of an introduction and then working through regression. So over the last few weeks, we kind of talked about what is machine learning, why we do it, and had a lot of great questions, which we've been answering around careers in this space. And then we're working through regression. So last week, we kind of touched a bit on what linear regression is, and then dived into data cleanup. So if you watch it, if you have been following along with the videos, I'll drop a link to the videos in the chat as well. If you follow along with the videos, last week we covered kind of up to part
9. Up to
part
video
9.
9, I believe.
Yeah, part 9. So we kind of talked a bit about linear regression. So we set the ideas, we kind of ran through a Jupyter Notebook, get it all set up. We looked at a diabetes data set and just ran some regression on that. And then we kind of talked about cleaning data. Before you can actually work with your data, it needs to be clean, needs to be good quality. So we kind of worked through up to video 9 last week. So this week, we're kind of diving in at video 10, where we go into linear regression, talk about correlation, polynomial regression, categorical features, and a lot of cool stuff around that. We'll be working through the code, answering your questions on it. Got some pictures to show you to illustrate some of the points. So yeah, Jeremy, to answer your question, we're kind of up to part 10, working to understand linear regression. I hope I ML better than I English. I really do.
And yeah, so Jeremy's saying, so we haven't yet hit the web app section. That's correct. So this week is just going to be linear regression, correlation, and one-hot vectors, that kind of stuff. And then next time we meet, which is in 3 weeks because of build, so we can't meet next week. We're not going to meet next week. So in 3 weeks, then we're going to be doing logistic regression. And so that will end the regression section.
Yeah, so we're not actually touching on the web app at all. So we're just doing regression at the moment. The idea is we're just doing a whole chunk of these videos, making sure that's of benefit to everyone. And then after that, if everyone says, yes, this is great, we need more, then we will go through and start adding classification, clustering, NLP, things like that. So yeah, we haven't hit the web app. So the web app that Jeremy's talked about is in the actual curriculum. There is a lesson on how to actually build a web app that uses what you've built. So, you use the model that you've trained around pumpkins, and then you actually then take the model out and then put this model. In fact, there's UFOs, actually. It's not pumpkins, this one. You're actually doing with UFO sightings. So you train a model for UFO sightings, and then you build a Python web app to actually kind of show it in use. Because at the end of the day, there's no point in having a model if no one's using it. I know we touched a bit on ML ops and kind of how to deploy these models a little bit last week, but yeah, so there's no point in building a model if you're not using it. So the section 3 Jeremy's talking about, it's kind of a great assignment for you to work through to take your model and build an app.
And so Mark is asking, what will happen after 26 weeks? And Jeremy says, we'll all turn into pumpkins. And that's exactly right. Thank you, Jeremy, for answering the question so accurately. That is so true.
So the rise of the machines will all turn to pumpkins. I'm curious. I'm curious now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23. Oh, it's 24 weeks till Halloween.
24 weeks.
24 weeks till Halloween. So we've already covered some of us.
Okay.
So 24 weeks time, we turn to a pumpkin for Halloween.
Yeah. But now to answer the question like a bit more seriously. So I think if you're done with this course, like once you're done with this course, what I would recommend studying next would be something on deep learning. Because studying these like the machine learning basics is actually really useful to then understand deep learning. Because deep learning is sort of like more like an extension of that, like it covers like bigger, doing the same thing with bigger data. And so I think you'll be really well prepared for that. And deep learning, it's very relevant today. And so that's what I'd recommend. I know for all the pumpkins learning deep learning.
If only Microsoft had an AI for beginners that kind of covered that concept, that'd be a really
I know.
to have.
Oh my God, you just did it! Like, oh wow.
Yeah.
Yeah.
So Marek, just a bit of history. The reason for like the 24, 26 weeks is we built these so that universities could run these courses. And the average university semester is kind of 12 weeks, 13 weeks. So we 2 lessons a week. So we kind of built this to fit in with the university semester. So kind of by the end of it, you should be confident in what's been touched on and able to go and jump in the next set of learning. And then, yeah, for deep learning, we have AI for beginners, 24 lessons, all about AI. A lot of cool stuff here. Genetic algorithms, expert systems, computer vision, CNNs, not the news network, but convolutional neural networks, object detection, kind of a lot of stuff where you're really diving into
transformers. Yeah, so like if you see like number 18 there, transformers, that will actually help you understand how GPT works, if that's something that's interesting to you. So if you make it all the way to week or class lesson 18 in the AI for beginners, then you'll be very well informed about how GPT works.
Because the T in GPT is transformer or something, isn't it?
Yep, generative pre-trained transformers. Yeah.
And we're not talking, robots in disguise. We're not talking like Optimus Prime. He says, pointing to his Lego Optimus Prime up there. They transform language tokens into other language tokens. Is that right?
Yeah. So in the case of GPT, they take in tokens and they produce the tokens that are logically follow those tokens. So they're more like so the transformers I use for like generation of text, but they can also be used for translation, which I think is what you were referring to. Like you can have like a bunch of tokens coming in one language and then you generate a bunch of tokens to translate that. In fact, when the paper came out, which is 2017, that was actually the intention of the paper, was for it to be a machine translation paper. But then people started looking at it and analyzing, and they're like, oh, we could just like take this little piece of the translation and we could just do generation. And so that's what's happening today, and that's how GPT works. It's
Okay,
basically.
so it started as a translation model and kind of grew from there.
Yeah, exactly. I mean, it's still used for translation, but like a piece of it was taken out, and now it's being used for generation. Yeah.
So we do actually touch on large language models prompt programming in lesson 20.
That's cool.
That's cool.
Yeah.
So we,
yeah, very
yeah,
nice.
touched on GPT. So there's a little bit here on GPT.
Yeah.
Maybe out of date. It's saying the latest model only available is GPT-2. Mentions GPT-3. Obviously, we're up to GPT-4. But yes, there's some stuff in there for actually playing with these. So
for sure.
So yeah, that's some of your next steps. So Marek jumps in to say, saw some next steps. Example: web dev for beginners, IT for beginners, data science for beginners, AI for beginners. So yeah, what we have is we've built a number of these curricula. So this may not be the next steps. It depends on what you want to learn. But we have web dev if you want to learn how to build web apps, and it's JavaScript, HTML, CSS. Again, it's kind of the fundamentals. IoT fundamentals. That one's the best one of the lot, and I'm not just saying that because I wrote it, but because it is the best one. And obviously, data science goes more into how you can prepare your data ready for machine learning than AI, which you just touched upon. So yeah, if you find as you do machine learning, you like the data cleanup, data science for beginners is your friend. If you want to dive more into the deep neural networks and all the cool stuff, AI is your friend. If you want to think about how you can use machine learning with Internet of Things, we do touch on some ML stuff and IoT for beginners. You want to build the web app to host it, web dev for beginners is your friend. So this is kind of our free curricula that we have. And if anyone's watching this and you're a teacher, you want to use this curricula, they're free to use. They're fully MIT licensed. You can pull out whatever you want. Just use bits of it. However works for you, they're there for you to use. And got any questions about how to use them, get in touch. We have discussions on the different GitHub repos, and we can help you actually run these in your classroom.
Yeah, and also Merrick is saying, I see that Microsoft Azure Subscription is required, or would it be good to have an account? And it's actually not required. For these for beginner kind of videos, we're really, or not videos, like the curriculum, we're not requiring or even recommending an Azure subscription. This is really just to help you get the basics of AI, non-Microsoft technologies. There are also Microsoft certifications for Azure that you can do. In fact, that would actually be a really nice sequence, even like after the AI for beginners, then to do like an Azure kind of training to then understand how to use GPT on Azure and that kind of stuff. So that would be really cool. But for these for beginners courses, you don't need to have anything other than a computer.
Well, I will say for the IoT for beginners, you do need an Azure subscription for the IoT one because IoT relies on having a cloud service. You are connecting a thing to the cloud. When we first start off, it's just you spin up you use a free open source MQTT server, but eventually you do have to do the cloud connectivity. That's just the nature of the Internet of Things. You have the thing, you have the internet. But no, for the others, we do have guides on how you can deploy to Azure, but yeah, absolutely not needed. Vamsadar does ask, can someone share the link of the previous sessions? So what I'm going to do, I'm going to drop a link in the chat to a playlist from the Microsoft Reactor. And this actually mixes in the videos as well as the previous sessions. So we've got two playlists, one which is just the pure videos, and then the one I just dropped in the chat mixes in the previous sessions. So you can watch the videos, then you can join the sessions where we work through it and answer questions. A lot of great Q&A topics. In there.
Also, Kevin, we kind of skipped that one. Kevin says, I love the videos being a nice intro, and the exercises are a great way for practical learning. Thank you, Kevin. And that reminds me that I do, like, of course, you can just watch the videos and leave it at that, but I do recommend that you follow the curriculum, so follow the GitHub at the same time that you watch the videos. That's what they're intended for. They weren't quite intended to be just watched like that. And actually work through the exercises and see if you can follow, if you can write your own code, right? And also, as one thing that was a confusion about this later. So we're telling you to like put your code in this empty notebook, but there's also solutions in each chapter, and I think some people are missing that. So can we show them the solutions, Tim?
Yeah, sure. So actually, I just open it up in here actually. So if we take regression, for example, look at linear regression. We have a blank notebook Well, so just a pre-configured notebook that kind of comes from the previous one. So in section 2, you clean some data and you write that notebook. Section 3, we give you the notebook with the data cleaned and you fill in the rest of it. But if what you can do is in the solution folder here, we have the whole notebook with all the solutions already run. So all the code already in there. So you can just run it and see if you want to see what's there, or then you can go through kind of reading the code, understanding the code. So it's all there. All the instructions are in the README. The README here gives you all the details, all the instructions, tells you what code to write, explains the code. You can drop it in this empty notebook. But then if you want to see the end result, we have that solution there.
That is correct.
There's even
what?
It's just a temporary placeholder. Someone's teasing us about Julia.
Oh, we planted that seed, didn't we, Jim? We gave them the idea. And
well, this was from 2 years ago, admittedly. So, someone else had the idea 2 years ago. Just no one's kind of written in Julia. So, if anyone likes Julia, this is open source. So you can write the Julia versions of all of this. We'd love you to submit that.
Yeah, let's plant that idea again. Yeah, and you know what? Somebody already created a folder for you, so you don't even need to create the folder. You just need to add the files to it. Yeah. Easy, right?
Easy. Yeah. So if all of you has homework, you can get that done this week and get the PR.
Yeah.
Great.
Exactly. So Rajesh has a good question also, Jim. I have done advanced level of AI training in IBM Cloud. Should I start from the beginning again? So it depends. What did you learn in that training? Because there's many ways to teach AI. If you learn it at a university, you're typically going to learn it from scratch. The kind of stuff that we cover in the ML for Beginners course here. So you're going to learn a little bit of the math. You're going to learn regression. You're going to learn classification. You're going to learn kind of the basic building blocks that kind of everything else is built on, really, right? But a lot of time when you're doing these certifications from different companies, you're trained on their cloud. So you're training more like how to use the AI and not so much how, you don't really learn it from the beginning quite as much, not all the details of what it took to get there, right? So it depends. So it depends on two things. So first, what did you learn in that IBM Cloud training? Was it the how you would learn it at a university, or was it specific to their cloud? And second, what's your interest? Because for a lot of people, learning just how to use it on the IBM Cloud or Azure, it's enough. That's what they want to do. For other people, they really want to get into AI. They want to understand how all the nuts and bolts work. They want to be able to create new models from scratch. For those people, then I recommend the course that we're presenting here, because it really kind of gives you that solid foundation.
Yeah, so I guess, Rajesh, a question for you. Did you just learn how to use Watson, or did you actually learn fundamentals?
Right. Exactly.
Yeah.
Totally.
Kevin has a very important question. How can we determine the ideal balance of playing Zelda, studying ML, and sleeping? I mean, Zelda first, I'm guessing. And then, I don't know.
Sleeping.
Are you young enough that you don't need to sleep and you can study ML instead? At my age, sleeping comes first.
Sleeping is important, I would say.
But Kevin follows up with a more serious question. Do we need to know R? I saw a couple of models where R was used. So we actually have a choice in all the modules. Say all, I think most of them, of Python or R. They're all in Python. Some of them have R as an option. You don't have to know R to work through this content. But I guess B, R or Python? What's the right answer there?
Yeah, so at a more high level, like for your job or for just getting into the field, do you need to know R? And I would say the answer to that is also no. I would say Python is more used than R these days for data science. So I think if you're going to learn one, then I would invest in learning Python. However, R is extremely popular with statisticians. So for example, anybody, generally people that are in the statistics department, they will use R, right? So if that's your background, or if it's the kind of, the people that you're going to be working with at work, then you're more likely to be required to learn R in that situation. But other than that, I would say most data scientists these days that have a background in computer science or math or other engineering, they generally use Python. And so in the course, we give you the option. So whichever one you decide to go with, you can go with that. Yeah.
So I guess Mark's question sounds like a follow-up. So how can it help us with machine learning? So everything we do in Python, is that available in R? Is there like an R version of scikit-learn?
I'm not familiar with R at all, so I could not answer that question. I'm not a statistician. I'm a mathematician / computer scientist, and so I really don't know. But my understanding is that yes, like all the kind of statistical side of it, at least, would absolutely be well supported in R because that's where it's popular, right? So I can't imagine it not having support for that kind of stuff.
So I'm looking at the diabetes dataset one in R, and there is TidyVerse, which is a collection of R packages for data science, and TidyModels, packages for modeling and machine learning. So I'm guessing the same thing. We read some data, split the data, and there's a linear regression. There's a linear reg function.
Yeah, so Kevin's saying that he used R for his biostatistics class, and it gave him 4 programming habits. Yeah, I do tend to it is a thing, it is. I do see that generally people that come from a computer science background tend to not like be super thrilled with R and tend to gravitate more towards Python. It's a bit more familiar, it's a bit more in line with other high-level programming languages. And R tends to be a little bit less formal than those languages, and it tends to be a little bit more appealing to people who don't have a programming background. And I think that's why we see statisticians gravitating towards R and computer scientists gravitating towards Python. I think in the end they can do the same. It's more like where's your community? My community is in Python, so for me it's important to be there, right? The people I work with, the people I talk to are generally in Python. But if you're working in a, let's say, in a bio kind of company, I don't know, if you're working with statisticians that have either a bio background or a statistics background, whatever, that may be your world, and then you'll need to learn R. And I think, in the end, I think you can do the same things. It's just like what's comfortable for you. What about Java? I have not heard of anybody doing machine learning with Java, so I don't know.
It's definitely using it. I mean, we've talked about, I know we touched this a lot in the past. It's you build the models, and once you've got the models, somebody uses the models. So you have that kind of pyramid where you have the people who build the tools to build the models, then the people who build the models, then the people who build the applications that use the models. Those end applications, yes, Java will be used for that. All programming languages will be used.
JavaScript.
For that.
Yeah.
JavaScript, absolutely. You name it, you can code against a model in whatever language you want because you just deploy it as a REST endpoint, for example.
Yeah.
But I mean,
to create a model,
probably could.
Yeah. I haven't. I mean, probably could, but I haven't heard it being a popular thing. Let's put it that way. I don't think that there's a particularly large community around it, but that's just my guess. Machine learning in Java. Okay, so it seems like it's possible.
And there's probably TensorFlow for Java.
Models. Okay, all right. So it is possible. So I guess you could. I mean, if that's your background, right? Like, if that's what you're familiar with, just for sure, start that way, because you may, like, if you get a job, you may be in a world where everybody else is doing Python, you may have to switch. But if your goal for now is to just get started with machine learning and you already know Java, then why not? Yeah.
Yeah, because I mean, there's libraries for all the languages. It's like in the .NET space, there's like ML.NET. So if you're a C# or an F# developer, ML.NET allows you to build libraries for Onyx.
Yeah, exactly.
So you can use whatever programming language. And Marek, your question about deploying using Azure, I mean, you can deploy in whatever language that you want. So the whole idea, we've got like the Azure ML Studio allows you to build models, train models, and then package them up and deploy them, because they're literally just deployed as Docker containers. So it doesn't matter what you build your model in, you're just going to deploy that model and then call the model from your application code. Really, I guess it's whatever's the most efficient language, because how quickly can you build it? Because a lot of times it's not about how fast the code runs, it's about how fast you can build the code. But then with the code as well, how well does it scale on hardware? Because the more powerful hardware it needs, the more money you spend.
Yeah. And also there's a lot to be said for community, right? Like if you're in the Python world, you're gonna find more examples in Python, more articles that you can read and understand because they're written in Python. So I feel like it makes it a little easier to ramp up. But in the end, I think just starting somewhere is more important than starting in Python where everybody is, right? Like if you're not sure you want to be in this field and you already know Java, I would still say start with Java and then see if you get into it. And then if you do, and if you have the need to learn Python, then it won't be actually so hard to make that transition later. Yep.
Cool. So Rajesh comes back and says, as Watson notebooks. They did the projects. Okay. So is a Watson notebook just like a Jupyter notebook, or is it very specific to Watson?
I have no idea. Yeah. That'll be a question for Rajesh. Yeah.
Yeah, I guess Rajesh, question for you, because if you think we're when we have like a Jupyter notebook, where are we? Let's restart my code space. Yeah, when we have like a Jupyter notebook here, let's open it in Python. Yeah, it's just. Why are you not? Huh?
Maybe we have some error there.
Maybe we broke something. Let's broke something. So Watson's here, just like Jupyter Notebook. Okay, so it's just a place to run.
To run code.
Yeah. So there, that's what you're doing. If you're just running, if you were using things like scikit-learn to run code, then yes, it should be basically the same.
Yeah. Cool. Should we start talking a little bit about this week's topic?
Yes, and as we do, I think Kevin's asking a great question. So given a lot of exposure with packages, scikit-learn, pandas, numpy, matplotlib, I'm struggling differentiation what these tools actually do. Can you deliver a high-level description? I think the best thing we can do, if we wade through the code and kind of show you where each of the packages are used and what they do, I think that might be a good way to do it.
I will give a really high-level overview before we get there, though. So matplotlib is mostly for plotting, so for graphs, for anything that is visual, like when you want to see your data and understand it. Okay, numpy is more for doing tensor operations. So if you have vectors or matrices or n-dimensional tensors, then that's what you would use. So for example, for numerical programming, basically, right? Pandas it's usually used for its data frames. They have this data frame that is like a really nice way to work with your data and to display your data, with columns and rows, and the columns have names. So it's a higher level NumPy almost, or more like friendly NumPy. And scikit-learn is for the machine learning operations, like the training your model and fitting your model, making predictions, that kind of stuff. So that's a really good question. And I would say that as a beginner, those 4 libraries are really the key libraries when you're starting out with regression. Those are the ones that you're gonna use the most. And I would say in the future, NumPy will stay with you forever. Like with deep learning, NumPy is the thing. I would say that matplotlib and pandas are really important if you go more like the data science route. Like if you go get more into data visualization and interpreting the data that you have. So that's generally more like the data. If you do we have like an ML for data science or something like that. That's kind of what's covered there. It goes deeper into that data visualization, that kind of stuff. And scikit-learn is important while you're still in this machine learning stage, and then there will be other libraries that are used for deep learning, like TensorFlow or PyTorch. So that's kind of an overview. Does that help, Kev? Who asked, was it Kevin? Yeah. Let me know if that helped, Kevin, or if you have any follow-up questions. But I think Jim is right that if you go through the code, then that will also help you a little bit to understand what we do with each of those libraries.
Yeah, so I've got the notebook up here. So I'm actually going to run through the solution notebook rather than zip back and forward and copy and paste code. I'm just going to run through the solution notebook. And then as we kind of work through, we can kind of talk about some of the concepts. So the very first thing we're doing is we're loading some data. To train a machine learning model, we need data. So I'm going to run this cell here. So it's Jupyter Notebook. It's running in a GitHub code space. We touched on this in like the last few sessions. But so what we've got here, first thing doing, we're reading the data. So we need to load this data. We've got a CSV file. In fact, where is the CSV file? Here it is here. Here's our CSV file. Lots of data all about pumpkins. Look at all that data. There's a lot of data on pumpkins. And it's got things like the city where the pumpkins are grown, package sizes, types of pumpkins. Sorry, the city where it's sold, actually. Types of pumpkins and the date and the low price, high price, where the pumpkins came from, sizes and colors. And so it's kind of got data on pumpkin sales. So for anyone this is their first time watching these videos, first time joining us, you wonder what the talk about pumpkins was. It's because for this regression, we're working out prices of pumpkins. So we've got this big CSV file of data, and we need to load this in. So we use pandas to load that in. So that creates a pandas data frame. That's the right term, isn't it, B?
Yep.
Yeah. Yep. So we load this, and then this head function just shows like the first few rows. So we can kind of see there's the data we've loaded. There is a tail function as well, isn't there?
A what, sir?
Tail function, I believe.
Oh yeah, I think there is. Yeah.
So we can see the
end.
First 5.
Or no?
I just to show one of them. Only one.
Oh yeah, just shows the last one.
Yeah, there's the last 5.
Right.
There. So yes, this gives our pumpkins in a data frame, so we can then use this data. If you've not seen Jupyter Notebooks before, by the way, anyone who's watching has not seen these before, Jupyter Notebooks is basically runnable documentation. I think it's the nicest way to put it. You can have cells that contain text. You can have cells. So here's a cell that contains text. And then you have cells that contain code, and you can run code in Python, R, .NET, various other languages. So it kind of allows you to mix text and code, kind of that runnable notebook, runnable documentation, and you see the output of each cell. The last thing you run, you actually see the output below it, so you kind of actually see what you're doing. And then we're just going to clean the data. So this we covered this last week, so I'm not going to dive into too much detail. But first of all, we look for any data that's measured in bushels, because we have 24-inch bins, 36-inch bins, 50-pound sacks, 1 1/9 bushel cartons, half bushel cartons. So lots of different sizes of pumpkin measurement. So we need to normalize these, and we can't convert from 36-inch bins to bushels. So we're just filtering out the pumpkins that's packaged by a bushel. So all we care about is if it's in bushels, we can normalize the price. This is all using pandas to handle everything that we want to do. We define the columns we want. So what are the data points that we want to use? And then we just clean out columns that don't match our column set. We work out an average, we work out the price, because we don't want the high price and low price. We want an average. So we work out like an average price. We look at the month and we look at the dates of each sale, and we just get the month, because that's what we care about. We also get the day of the year. So how many days what date is in the year. So it gives a more even numerical spread. So this is all just using pandas. So back to Kevin's question, we're just using pandas here to manipulate our data. And then if our package is 1 1/9 bushels, we divide it by 1 1/9, because we want to get it normalized to price per bushel. And if it's half a bushel, we double it. So this again, we're just using pandas here, and we use this to manipulate our data. So that's kind of how we use pandas. So now we've got our data. We've got this here. That's kind of where we got to last time. So now we're going to well, actually, what we did last time is we did some plots as well, didn't we?
Yeah.
So we've got a plot here, because what we're trying to do is work out, can we predict the price of a pumpkin? So we've got a plot here, and this is where we use matplotlib. So matplotlib is a library for plots. We say plot, and it's actually linked into pandas. So on pandas, you can just call plot. That uses matplotlib to draw the plot for you, which is very nice.
Yeah, you could have used matplotlib directly, and here they just decided to use pandas, which just calls into matplotlib behind the scenes. So same thing.
But matplotlib allows you to kind of do more, doesn't it? You can do a lot more configurations. There's a lot more libraries. Yeah,
exactly. Yeah.
And so we're just plotting that. We've got a few price points based off the month. So it's kind of a spread there. And then we do the same kind of day of year. We draw a scatter plot based of day of year. And that gives us this lovely shape. It looks like one of those Rorschach tests, doesn't it? Where you have to try and look at this. What do you see when you see it? I'm thinking like a whale jumping out the sea with a spray at its back.
That's because you live in the Pacific Northwest. I also see whales everywhere.
Either that or somebody riding one of those bucking bronco horse things. You know, the ones you sit on, they do that. They kind of wave their arm. They're waving like a cowboy hat as they're riding this thing from a stay on.
Love it. Sure.
So that's where we got to last time. We kind of saw this big mass of dots. But can we use this? Is this good data, B? I guess the question for you, is this good data? How can we determine whether data in these plots, this is something we can use?
Oh, we need to look at the correlation, right? And so here's why. So if you're using, let's say if you have two different features and you're trying to predict, you're trying to, remember when we talked about linear regression, you're trying to find a line that fits the data, like the trend of the data. Well, if there's no trend in the data, you can't find a line that represents that trend, right? Because you can find a line, but it's not going to represent the trend very well, right? So what we need to find here, I'm looking at it and it looks like a bit of a kind of mishmash of points that doesn't have a lot of trend. And so, but does it, like there's ways to find the correlation using code, or you can just use it, do it visually to get a sense of it, to get some intuition. But basically, in order for linear regression to work, there's got to be some correlation between the variables that you're using in that prediction, right?
So I've got some pictures here to talk about correlation.
Yay.
So what exactly is correlation? Define correlation.
Correlation measures how related two variables are. Mm-hmm. So for example, here we have X and Y, and we can see just looking at the image that the larger the X, the larger the Y, right? Like, so I don't know let's say let's say if this is day of the year X and Y is price of pumpkins. Looking at this graph, we could say the later in the year it is, the higher the price of pumpkins is. Just supposing that this is not actual data, right? So that means that there's a strong correlation between the two variables, because I can kind of guess that if this is an actual, true data, then in December the price of the pumpkins is going to be higher than in January, let's say, because the later in the year the higher the price, right? So that's what correlation means, is how two variables are related. So let's look now at a no correlation or little correlation. Yeah, so let's say if the price of the pumpkins in the day of the year had like this representation, we don't really know. Like, we can have expensive pumpkins in really any time of the year, and we can have cheap pumpkins in any time of the year. So can we find a line that represents the trend of this point? Sure, we can find a line that best represents it, but is it going to really represent? Is it really going to allow us to make good predictions? Probably not, right? We can still make a prediction, but it's not going to be a very good prediction. And so that's why we don't want to be like, if this is the kind of data we have, we can't really do, we can't really use regression to make good predictions with it. So what do? We can look at other features in the data that we have, try to see what are the features that bring us correlation. Maybe we need to use a bunch of features and not just one feature in the X, right? Because you may have more than one feature that helps predict the Y. And so there's many techniques, that we go through in the course that will help you figure out what do you do when you have no correlation or little correlation, right?
But I think it's also worth touching on, because correlation doesn't mean causation, does it?
No.
So isn't part of this understand, yes, you could have this thing that looks like a strong positive correlation, but it could be coincidence. So I know we talked about it before, where someone built a vision model for determining skin cancer, and the model, the images they trained it on, if it was a mole that didn't have cancer, it was just a picture of the mole on your skin. If it one that did have cancer, had a ruler next to it and became like a ruler detector. So the correlation was, if there's a ruler, it's cancer.
Right.
So and there's always been jokes about, let's compare the rise in the cost of rent with the number of pirates in the Caribbean. And if you look over the past 1,000 years, the number of pirates has dropped off and rent has gone up. So are we saying when there's less swashbucklers on the seven seas, rents go up? Well, no. And yes, there is a correlation, but there's no direct causation. So it's kind of hard to use that to predict end values. So we need to make sure then that when we're actually looking at the data points, that the data scientists and the domain experts already established that there is a causation, which means we need to look for that correlation. Does that make sense? Does that sound right?
And I think that's why it's so important to have like domain experts when you're dealing with this data, right? It's important to have that data scientist, or even like that, either somebody that is both a domain expert and an expert in data, or have a partnership between two people. Like, let's say, have a doctor that understands about health, and then a data scientist that works closely with the doctor, that then together they can kind of make sense of the data and kind of what it actually means, right? And so, yeah, so that's really important. Yeah, I think we probably go into that in the data science for beginners, because that's the kind of stuff that I would expect the data scientists to get really into. Really understand the data, really understand everything about it and how it affects everything.
So Kevin's got a question about this. I know we touched on it in the past, but it might be worth touching on again. Would it make sense to remove outliers from the data set to improve correlation? Where's the balance to not manipulate data?
Yeah, so I think we did touch on that, but I think it's worth touching again because it's really important. I think, again, it comes down to common sense and understanding the data. So I'm just going to give you two examples. So if you're looking at survey data, like you sent out a survey to a bunch of people, you got back, and one of the questions was the age of the people, right? And one person answered 5,000. Okay, so you, just like with your human experience of being a person in this world, you can look at that 5,000 and think and say, okay, like, I'm just going to remove this data point because, it's probably, he's probably messing with us. He's probably trying to affect our results in some weird way, and I'm not going to let that happen, right? But let's say it's in the same survey, you ask, how many times did you get COVID? And somebody answers 8. You probably want to work with a doctor and ask them, is it really possible that this person got COVID 8 times, or are they just messing with us, right? Like, because you don't want to just remove a data point thinking, oh, I don't know anybody that got COVID 8 times, so I'm just going to remove it. That's where it starts getting dangerous. Like, you don't actually know until you talk to somebody who's an expert in the field that 8 is an outlier for somebody for a number of times of getting COVID, right? Just because you don't know anybody, or just because you haven't heard of it. So that's where I think I would draw the line. I think it's really important to be careful to not remove outliers just because you're not getting good results. This data isn't fitting because there's these points over there that make no sense. So I'm just going to remove them. Oh, poof, done. 90% accuracy. I'm good. I did my job. That's what we don't want to happen. And that's why it's so important to have experts in the field and data scientists that really care about the data. So hope that answers, Kevin. Hope that answers that.
Yeah, because there's been every now and again you kind of hear on the media about here's a scientific study that was done that proved this, and actually no, they deleted important things from their data, and we've now got a drug that's being released that's dangerous because they had a couple of outliers where people died or whatever, and they just cut those out of the data because they didn't make the data nice and clean.
Right. Yeah, totally.
So with this correlation, we can actually work out a number, can't we? This is core function.
Exactly. Yeah. And so the way that core function works is it's going to give you a value between -1 and 1. And if it gives you a value closer to 1, it means that you have a strong positive correlation. If it gives you a value closer to -1, it gives you a strong negative correlation. In fact, Jim, I think we have an image for strong and negative correlation Just wonder if you have that one there. Maybe
trying to-
not. Okay, so the strong negative correlation would be like the positive one, but kind of going down, but still kind of forming a line of like these points being very aligned, right? So whether you have the line going up or the line going down, that's good. That's strong correlation, and you can probably use those variables to make predictions, right? Those features to make predictions. But if you have something close to zero, it means that your points are like scattered everywhere, and then at that point, you know, you can still make predictions, but they're not going to be good predictions, basically. And I think that's why it's so important to kind of measure this. You know, you can get a sense of it looking at it visually, but at the end of the day, having a number, it's helpful. Yeah.
So,
So
Kevin,
there,
some shady papers always going for that good p-value.
Yeah, p-values are important too. Oh, yeah.
What
So
is a
yeah,
p-value?
so it's a statistical measure of. Can you help us, Kevin? Let's just look it up. It's a statistical measure of like where in the curve you get like false negatives and false positives, something like that. Again, I'm not a statistician, but it does come up a lot, p-values.
So it is the probability of, zoom in a bit. It's the probability of obtaining test results at least as extreme as the result actually observed, under the assumption that the null hypothesis is correct.
All right, there you go.
That means nothing to me. Is there a definition that's not Wikipedia? Because Wikipedia was great.
I'm sure there is.
A p-value. Oh, here we go. Bing chat. There we go. A p-value is probability measure of finding the observed or more extreme results when the null hypothesis of a given statistical test is true. Doesn't really help me. Used to quantify the statistical significance of the results. So basically how good the results are. The smaller the p-value is more likely you are to reject. Okay. So basically it's a measure of how good it is.
I guess. Yeah.
Yeah. Lots of statistical words I don't know.
Yeah.
Okay, so our correlation number then, we're minus 0.15 and minus 0.17.
Yeah, and that's like really close to zero, kind of. So these are not good correlation values. Like I wouldn't expect month and price to be related, or day of the year and price to be related with this data. I wouldn't expect to get good results with it.
Okay, we have a question actually from Mohammed about confusion matrix. I think we come up to that a bit later on, don't we? So, Mohammed, we will get to your this later on, when we'll dive into confusion matrices and actually measuring
variables with strong correlation and the ones with weak. Yeah, that is true. Like you can get visualizations for variables that are strongly related, variables are weakly related. So and that is important. Yes, you can absolutely get that. I don't think we do that in this course, but that's a very good observation. Yes.
Okay, so our correlation is not great, is it? Our correlation is
not great. No,
it's not good. But we're just looking at the day of the year and the price.
Yeah.
So, you know, is there a better things that we can do? And one thing we do here, so going back to Kevin's question about using different bits and pieces, we're actually plotting, taking advantage of Matplotlib to plot on one chart. We are plotting groups of pumpkins by their type. So we're finding some colors, we're going through our pumpkins. I'll still use some pandas data frames actually, but using Matplotlib for that, and it's plotting multiple plots in one place.
Yeah, and now we have a blue whale on a red sea.
Do you get blue whales in the Red Sea? I thought they were in the Pacific and the Arctic Ocean.
I know, right?
So yeah, we have this
sense.
fairy tale tucked in there, but we have this big blue area here, a couple of little blues there, and the red is very much grouped together. So we're seeing definitely that it's grouped together by the type. So this is kind of what we're talking about when you think about the X and Y. Yeah, we're predicting price on the X. It's not just necessarily about the day we're saying maybe it's the day and the type. There's a link between that as well.
Yeah, I think what we do here is we actually filter out 3 of the types, and we just keep the 4th, and we just decide, okay, so I think it's the pi type that we keep. So we just looked at it as like, okay, so what if we filter, just take like this red blob, I believe that's the red blob, the pi type, and just use that. Yeah. So what if we just keep the red blob from there and use that to see if we can get good correlation, right? Because if we can, then we can at least use that to make predictions. And I don't know what happens. I don't remember what happens. I don't think we get, I think we get a little bit better correlation, but not a lot better.
Let's run the code. So do the same thing. Again, we're using pandas. We're just filtering out everything with the varieties pi type, and then we run the core function. So core, actually, that comes with, is that pandas? Yes, it is. It's
pandas, it's on the data frame. Yeah, it's on the data frame.
Using pandas.
Yeah.
So this is our plot
new
with
data.
Just pi type.
Yeah.
And this is our correlation.
Yeah. So it's a little bit better in the sense that it's a little bit further from 0, but it's not great, right? It's not close to -1 yet, right? So can we make predictions? Yeah, we can make predictions, and we are going to make a prediction because we can do it. We can try to find a line that gives us a trend of those points and make a prediction using that line. But because the points are kind of a little bit everywhere, it's not going to be a great line, and it's not going to be a great prediction. Yeah. And that's kind of like the danger of these things, is that you can always make a prediction. You can always find a line, regardless of how bad your data is. The packages, not the APIs you use, will always give you something. They're never going to return to you, oh, sorry, your data isn't good enough. Go back and get better data, right? You're going to be like, oh, this is the best line I can find, and this is the prediction, right? But I think it takes a little bit of experience and knowledge to be able to not make the mistake of making predictions with data that is meaningless, that doesn't mean anything, and then say, oh, but data machine learning claimed that, we should be doing this because that's what I get in the results, right? So it's really important to understand the data, to really think through it, and to use your best judgment.
Yeah. And that, I guess, that's where things like this correlation score and some of the other measurements come in, don't they? They tell you how good your data is. So you can publish a model and say, I've got this model that can predict whatever. I can predict stock prices based off the flight of birds, whatever it is,
Right.
And here's my model, and it's great. And by the way, here's my scoring of it, which says it is terrible. Without that score, it just becomes, it's bad. You should always publish the score with it, so you know how good it is going to be.
Yeah.
So let's do that. Let's actually build a model based off this and just see how good or bad the model is. So this is where we flip to scikit-learn. So this is what the scikit-learn package does. This has got this has the linear regression and all the model stuff in it. So we use pandas to load our data, get our data ready. We use matplotlib through pandas to plot it so we can make decisions, and then we're using scikit-learn to actually build our model.
Yeah.
So we import the packages. And then I'm just going to run some code here to actually build the linear regression model. We touched on kind of how this works before, but essentially our X values are the day of year and Y values are price. That's all we're doing. We're saying day of year and price. We do our train test split. So we need to have some data to train our model and then data to test our model. There's no point in training it and then not actually validating it as we go through, because we're kind of, it will, as the model is trained, it will work something out, test it, see how good it is, work it out, test it, see how good it is, and so on. So we create our linear regression model. We give it our training data to do it. We then give it our test data and run our prediction to kind of get how good our model is. We're using an 80-20 split, so 80% of the data train the model, 20% to test it, and then we print out our error, our mean squared error. And our mean squared error is 2.77 or 17.2%. Is that good? Is that bad? What is a mean squared error?
Yeah, mean squared error is a calculation. I don't know if we get into the math. I think we do in the videos. I'm not sure, but it's basically a measure of how much error you have. And so in this case, you may have an error of 2.77 on average when you make a prediction. And so, yeah, so generally you actually calculate, I think, the square of the error, and then I believe here you just remove the square to get like an actual value of what your error is.
I don't think I have the maths for that. We've got
You
stuff
don't?
for logistic regression, but I don't think I have the maths for
Okay.
mean squared error.
Anyway, so it just tells you, you know, what is the mean error that you're gonna get, right? And 2.77 in this case is pretty high because, you know, we're seeing prices of, I don't know, like anywhere between like 30 and 60 or whatever. So I don't know what the prices were, but it's high, and you're gonna see that as we, you know, refine this, you're going to see that the error is going to go down, right? So you can start with an error and look at it. Okay, you know, I don't really know if it's low or high. I don't really have a good feel for it, but let me do a bit of finessing of the data and of the techniques and see if I can get it lower, right? So eventually you'll see that we're going to be able to get it lower by improving the kind of data that we put in the model and improving that correlation, basically. No.
So this is basically saying then, if I get this right, that on average, when we make a price prediction, we'll be out by 17.2%.
That's my,
so
yeah.
If the
exactly.
price is 100, we might predict 117, or we might predict 83, something in that range. So
Yeah.
we want to get that error as low as possible. It'll never be perfect, will it? It's never going to be perfect.
Right.
You know, we look back at our linear regression. You know, we're always going to have, there's never a direct line that touches every single point.
Exactly.
That's bad.
Yeah.
So we're always going to be out, but just how close can we get? I guess sometimes that might be okay. If you're within 17%, that might be okay depending on the situation.
Depending on the situation, yeah. Depending on the situation, yeah. So that there's also that, you know, you need to understand your data and make a judgment call, right? And all of this is subjective, and I think that's why we need, you know, good people doing this kind of work, is because it takes a lot of decision making and kind of you know, really using your judgment to make all these decisions. And there's a million decisions that you need to be making as you write a little bit more code and make the next experiment and all that, right? Yeah.
There's also, as well, don't need to think about false positives and false negatives. I guess that's probably comes later on. But if you're wrong, does it matter which way you're wrong?
Yeah, you're totally right. That is also tied to the kind of data that you have, and there are measures for that. And if you know, depending on your data, if you realize, oh, I can have false positives but not false negatives, then there's a way to measure that and then to optimize for the thing that you want, the thing that is important for your particular data. And again, that's data dependent, right? So for example, if you're detecting cancer, it's okay, sort of, if you tell, you know, if somebody comes out positive and they're not actually positive, because then you test again and again, you know, and then you realize, oh, they don't actually have cancer. You know, if you test again, they're like, oh, they don't have cancer. It was just a false positive, right? But if you have a false negative, that's pretty bad, right? Because somebody who actually has cancer could be being treated, and they're not, so they could die, right? So if you have a false positive, somebody dies. If you get a false negative, somebody does a second test or has the hassle of going to the hospital twice or whatever, which is not so bad, right? So in a situation like that, you want to optimize for, you know, it's okay if we have false positives, but we definitely don't want to have false negatives. And we're going to get into that later in the course. We're going to look at measures for that. Yeah.
But again, it comes down to, you need to pair with someone. You need that domain expert. You know, if you're doing cancer detection, you need to work with the doctor to find out, is it a good thing? Is it a bad thing? You know, in general, I guess a false positive is probably the least worst, because if the positive then kicks off a manual process to do something with that, to test for it, it's better to do that and waste time than it is to get a false negative and people die.
Right.
So that domain thing.
Yeah, totally.
Cool. Let's just do one last thing. We're almost at time for today. So one last thing. We can actually plot a line, can't we? So plots. So this is using matplotlib directly. So Kevin, back to your question about using the different libraries. We're using this directly to plot two things. We're plotting our X test data against the Y test. So we're plotting all our data points, and then we're plotting our prediction.
The prediction. Yeah.
So when we split our data 80-20, I ML better than I English today, I really do. When we split our data 80-20, the training set, the testing set, we've got the 20% that we use for testing. We just plotted that here, and then we've drawn a line. And you kind of see we're kind of in the middle. And yes, it kind of on average, yeah, those points kind of average out to this line, but you can kind of very quickly visualize that we're a long way from the line. And when your prices are kind of in the 12 to 22, we don't want to be this far away from the line. That's not so, it's kind of not so good, is it? If we were, you know, if this was a much bigger range, maybe it's better. But at this point, that's not great, is it?
Yeah, it's not great. Yeah, I mean, just looking at the points, we can see, you know, yeah, this is the best line that represents a trend, but there's really not much of a trend there. So
okay, so can we do better? And we're at time. So what we can do tomorrow, we're back here tomorrow.
Yeah.
And we're going to carry on working through this, and we're going to do better. We're going to do better.
Yes.
Sneak preview. This isn't just this isn't just us showing that, hey, pumpkins don't have any correlation.
Right.
You know, if you watch the videos, you'll know that things get better. So yeah, come back tomorrow, same time, and we will work through this even further and kind of show just how we get these predictions working. So thank you everyone for joining us. Hope this was some good stuff and great questions from everyone. Really glad to have you with us. Thank you, B, for taking time to join me with this. And yeah, we'll see you all next week. We have put a link to a survey in the chat. We do appreciate you filling in our survey simply because we want to learn, are these the right kind of sessions that you want? There's no point in us doing this if you're there going, but you should be doing something else. I really wish you would do something else. So please give us your feedback. Let us know whether you like it or what we can do better next time. But otherwise, thank you for joining us. Thank you just for you and Quinsab. Great to have you with us again. So yeah, we'll see you all next week.
Yeah, thank you. Bye.